Hello and welcome to 5 Minutes of Postgres. My name is Lucas, and today I want to talk about two improvements to the new pganalyze view in Postgres 16. We previously spoke about pganalyze in a prior 5 Minutes of Postgres episode, as well as a blog post. And just for quick reference, pganalyze lets you track all the I/O activity on your database in one aggregated view in a way that wasn't really possible before Postgres 16. Shortly before the feature phrase for this new Postgres release, two new additions got added to pganalyze. The first addition is the ability to track shared buffer hits in pganalyze. This was authored by Melanie Plageman, committed by Anders Freund. And what this does is it tracks the shared buffer hits in pganalyze so that you can calculate a useful cache hit ratio for your whole database server. The way it enables this is by letting you count the hits on database level whilst filtering out reads that are done by buffer access strategies. The motivation here is that oftentimes people recommend looking at shared cache hit ratio as a way of saying, is your Postgres database still reading from memory most of the time? Are things in cache most of the time? Or do you need to, for example, have more hardware or optimize your database? The way that these recommendations are made today is that they're looking, for example, at pgstat database. They're looking at the blocks read and the blocks hit counters. They essentially represent how many blocks were read into shared buffers and how many blocks were already existing in shared buffers when you were trying to read something. And so this read was skipped because that was already in cache. The problem with this methodology of counting this as cache hit ratio, it neglects that there are certain operations in Postgres that do not use the full amount of shared buffers. And most importantly, for example, if you have a large sequential scan or if you have vacuum running, those use what are called buffer access strategies. For example, you can see here in the new pganalyze view, there's a way to track these separately. There is the concept of a normal I/O operation. This is if you just have, let's say, query doing an index scan for loading a couple of blocks for that. You have vacuum, which is one of the bulk access strategies that is used by automating processes, for example. And there's bulk read and bulk write. Bulk read, for example, could be a sequential scan over a large table. Previously, what would happen is that if you counted the hits and the reads, you would actually see a higher amount of reads because of such bulk reads, because they could never keep the whole table in the shared buffer cache. That would lead to these cache hit ratio numbers to be incorrect and to feel like you're not having things in cache. And even if you increase your shared buffers by a lot, it wouldn't have improved your shared cache hit ratio. With this new addition, you can say I/O context normal, and then you can look at this new hits counter, which is in pganalyze, and so that way we can add up the reads, add up the hits, and then say how many hits divided by that sum for the normal I/O context, and that way we actually have a correct cache hit ratio for our database server. The second addition that was made to pganalyze, also by Melanie Plageman, is to track I/O times in pganalyze. This is really exciting because it adds a whole other dimension to this counting of I/O activity. Previously, pganalyze was just counting individual operations, but you didn't really know how long that operation was taking. And that's a problem because behind the scenes, there's an operating system page cache that can influence whether things are in cache and also how I/O is batched together. One I/O is not the same as another I/O. One might actually be really slow, the other one might be really fast. What matters is when you see a spike in I/O activity, was there also a spike in I/O time? And so with this new addition of read time or the write time columns, you can now see how much time the system actually spent reading data or writing data, and through that have a closer correlation with the actual underlying I/O activity. All in all, two more reasons why pganalyze is going to be an amazing addition to Postgres 16. I look forward to using it on production databases, and we'll see what else future Postgres releases bring to this new view. Thank you so much for listening. This was 5 Minutes of Postgres. Subscribe to our YouTube channel to hear about next week's episode, and talk to you next week.